So we are finding the domain of transformed logs. Yesterday, actually a college professor did not review what they did yesterday, but I'm going to because it's not college, it's still high school. Yesterday, we talked about taking or finding the domain for log functions that have been transformed. Like this is the parent function, log of x. This is a transformed one. It's changed. It's been squared, and now it has a minus 36. But we still want to know about, well, what's its new domain? That would be really, really easy if I gave you a picture. But they didn't have pictures. They just had equations. So we used algebra to figure it out. There were two characteristics that have to be true about whatever you're taking the log of. I was about to ask you what they were. Do you want me to ask you what they were? Let me do the college professor. What do you want? Okay, yeah, thank you, because I wasn't handling not asking. What are the two things that have to be true about the x that you're taking the log? Positive and not 0. Okay. And we handled the can't equal 0 part first by taking whatever's inside here and setting it equal to 0 and solving. So we move the 36 over, square root both sides, and we get positive negative 6. All that is the two numbers that would make it equal 0 inside here. Like if you took the 6 and you plugged it in here, you'd have 36 minus 36, which is 0. And then you'd be trying to take log of 0. You can't do that. It's undefined. If you put that in your calculator, it would tell you you can't do that. But that's only two values. We want to find any other x's now. So these are the x's that would make it 0. We want to figure out which x's would make it negative so we can avoid those. So then we went to, do you remember what was our thing for doing the positive thing? The positive section or the positive stuff? What did we do? We used the graph, right? The number line. So this represents our x-axis. And we know these two don't work. So we're going to go ahead and put open circles there to show they're excluded. And then we need to know which other x values will keep it positive. And we can do it. We don't have to test every single x value that exists because that is a never-ending job, quite literally. All we have to do is test one in each section. Like we can test negative 7 here, 0 here, and 7 there. And we're going to plug those numbers in. So x squared minus 36, this is negative 7 squared. Remember, when you're plugging a negative number into something that's squared, the negative is included. So it's negative 7 times negative 7, which is positive. What's 49 minus 36? 13. I don't really care that it's 13, right? What do I care about? That it's positive. So that means that section to the left of negative 6 is good. It checks. It makes us happy. So this section has checked out. So then this middle section's easy to check. You put 0 in for x squared. You get negative 36. How do we feel about that? No. It's bad. That does not check out. And then 7 is going to give me exactly what negative 7 did. Why? Why is it going to give me the exact same thing? Because it's squared. So that will just give me 13, which we already said we're happy about. So that means everything to the right of 6 will work as well. And then we just write it in interval notation. The interval on the left is negative infinity to negative 6 with parentheses. This one is positive 6 to positive infinity with parentheses. What do you join them with? A u. Union. Okay? Feel good about that? That was a quick overview of yesterday's lesson. Raise your hand if you did the homework. Excellent. Any questions on the homework? It was just like the notes, right? And by the way, you should have all done the homework because we did this whole thing together and then it just left 3 questions. I mean, seriously, y'all, 3 questions. Come on. Just like the notes, too. All right. Let me get you your notes for today. We skipped the last 2 slides. We're getting straight into the work. The directions say solve each equation, write answers in exact form and in approximate form to 4 decimal places. So I have ln of x equals 1/2. What do we call ln? It's the what kind of log? The natural log. Okay. What did you say? Okay. So our goal here is to get x by itself. Right now, there's a log being performed to it. One thing I need you to understand about this is that when we solve this equation, what do we do to both sides? We divide by 2. Here's why. And that gets the x all by itself, right? Kind of. Not really. So I'll have to get to that in a second. The reason why we divide is because originally we were multiplying. And division is the inverse of multiplication. You good with that? Division is the inverse of multiplication. That's what you do to solve. You do a bunch of inverse operations. This equation, it's not ln times x. It's the natural log of x. This log is being applied to the x. So in order to undo log, you do the inverse of log, which is what? What's the inverse of log? Exponential. Very good. What do we use to convert from log to exponential? The lasso. Exactly. Okay. So 2 days ago, we practiced with the lasso going from log to exponential and vice versa. Now we're using that skill today in an actual equations. So here's what we're going to do. Here's what we're going to do. We're going to use lasso on here, but there's no base. It's not 10, it's e. Natural log is log base e. It's just another way of writing it. So the first step in this problem is to rewrite with base e. So log e of x equals 1/2. Okay. So now that I've done that, I need to go from log to exponential form. I'm doing the inverse of whatever is happening to the x right now. Bless you, which is log. So we're going to do lasso. After this problem, I'm just going to write the word lasso. But in this problem, I want to sort of expand a little bit. Lasso to convert from log to exponential. That's the reason we're going to do lasso. And lasso starts where? With the what part? The base, right? What's our base here? The E? I heard someone say E. So it starts at the base. It goes around to the other side and comes back to where it started. So I've got E to the what? 1/2 equals x. I have solved for x. See how it's all by itself now? There's no log happening to it. There's nothing else being multiplied or added to it. It's all by itself. I'm done. This is exact form. The directions ask you to also find approximate form. You need a yellow calculator for that. So please go grab yourself a calculator if there's not one already on your desk. Is exact form because as long as it's just E, it encapsulates all of that number. Remember, E goes on forever and ever and doesn't end, right? However, once you convert to a decimal that you've rounded, like we've truncated this after 4 places, there's a whole bunch of numbers that come after here. Well, we've cut all that off. That's why this is called approximate form, and that one is exact form. And just so you know, approximate form, like the actual words, is really fun to write. So you should play with it. It's fun. Like, do your script. Okay, so this was baby problem with log. Now we're going to do a baby problem with guess what? Which is? Yes, it is. Thank you. An exponential equation, right? Where x is in the exponent position instead of the log position. So we have this baby equation. X is in the exponent position. So I have to do the inverse of exponent, which is log. How do we go from exponent to log? We lasso. So do your lasso, and I'll do my lasso. And we'll see if our lassos match. Bless you. Did you get 10 to the 0.024 when you lassoed? And that's it, because x is already by itself. There you go. There's your exact form. Use your calculator to do approximate form. Negative 1.6198? Yeah? On your calculators? On your dials? All right, so those were just baby problems. They weren't the real problems. Yes, ma'am. Yes. Because it's an exponential right now. Oh, wait. Oh, yes, I'm sorry. I did the whole thing wrong. Anyone else besides Caitlin notice what I did wrong? Yes, sir. Yeah, did I even do anything? No, I didn't. I'm so sorry. Dang, and I was recording. I'm so embarrassed. Okay. All right. Let's go back. And it's funny, I mean, not ha-ha funny, but all day I have made a point of saying what I'm about to say, specifically so that people didn't do exactly what I just did. This thing that I'm about to tell you. Sorry, 7th period. Here's the thing I've been telling classes all day. When you're switching to log, you might get confused because there's no log like in this problem. You have to literally write down the letters L-O-G to get started on the problem. Otherwise, you're just going to do exactly what I just did. I can't believe I did that. Y'all should get your money back for your education. Your education day. You need a refund. It's log base what? 10 of 0.024 equals x. And that is your answer. And I apologize. Yes, ma'am. One thing about base 10 is it's a common log. You actually don't have to write it at all. This is equivalent to writing log of 0.024 equals x. Those are the same. It's only base 10 that you can do that with, though, where you don't have to write it at all. It's called common. Thank you, Caitlin, for saving the day. Now let's go to the real equations. On these equations, all those words we skipped at the beginning of your notes told you to do this when you're solving equations. Isolate your log term or your exponential, depending on what you're starting with, and then convert forms using lasso. Which form is this equation in, log or exponential? Okay, so at some point we're going to have to do lasso to convert it to log, where we will be using the letters log. But we cannot do lasso until we've isolated the piece with the x on it, which in this equation is that, the base where x is in the exponent position. So we have to undo everything else that's happening to it. We have to undo times -3. We have to undo this plus 2. And it's just like if instead of that e to the 0.4x, if you had this equation where there's just a regular variable there, see, everything else is the same except I put an m where that box is over there. It's the same math to get started. In this easier equation, you would do what first? Subtract 2. You would get that over, and then you would divide by -3. It's the same thing we're going to do over here. Okay. So our first step, or our first several steps, is to isolate the e to the 0.4x. And we do that by subtracting 2 first. So I've got -3e to the 0.4x equals -9. Then what? Is it time to lasso? Divide by -3 first. You don't lasso till the e is all by itself. So I've got e to the 0.4x equals +3. So there's my isolated exponential term. Now I can lasso. You start with the base. You go around. If I'm converting to log, what do I need to write down first? L-O-G. And I know I need that because I started with exponential. The only other thing I can write it as is log. So log base what? E. Log base E of 3 is good. 0.4x, very good. Now on the other problems, once we lassoed, we were done. How come I'm not done here? I heard a 4. I heard what? I have to take care of the 0.4. It's 0.4 times x. That's not hard, though. What do you do to both sides? Divide. Just divide. It's currently times 0.4. We're going to divide by 0.4. So I have x equals log base e, which I'm going to write as ln. You do not have to. I will accept it if you leave it log base e. But I do expect that you can recognize it anytime, that ln and log base e are the same. Which form is this? Exact or approximate? Exact. Use your calculator to find approximate form. 2.7465, yes? Ish. That's why it's approximate. It says approximate form. You try the last problem, please. Take a few moments, try that all by yourself. All by your lonesome. Talk about it, talk about it. Brianna, what'd you do first? That's correct. Who else subtracted 9 first? Perfect. And when you do that, you get what? Negative 5.4? So my first step is I'm isolating the log term, which is log 2x. What'd you do next, Brianna? By negative 4? What do y'all get on the right-hand side when you do that? 1.35? I act like I don't know, but I've already done this 3 times today. So then that leaves me log of 2x. So I can just do this, right? Obviously, you know this is going to be wrong because the way I asked it. Can I just do that? That doesn't even make sense, right? Log is a function that's happening, so I can't do that. Feels like I want to, but I also can't divide by 2 just yet because log is happening to the 2x. Like it is like a function that's being performed on it. So the 2 and the x are not currently available for mathematical operations. We have to release it from the bonds of the log. And so we do the inverse of log. What is the inverse of log? Exponential. What do we do to go from log form to exponential form? Lasso. And where do we always start with the lasso? Well, that's a problem. I don't see a base. It's 10. Anytime the base is not written, it's understood to be 10. Only 10 can do that. It's like got special privileges. Okay, so now we're going to do lasso with 10 for the exponent. So we start at the base, we go to the other side of the equation, we come back to where we started, and we use that path to set it up. So I've got 10 to the what? 1.35 equals 2x. Still not done. I have one more step to get x all by itself, which is what? Divide by 2. You may not do 10 divided by 2 right here. It's not allowed because the 10 has an exponent on it. Okay, you can do 10 all by itself divided by 2 all by itself. But the only time you can do math, see, once 10 has an exponent, it's now a base. And the only time you can divide stuff with it is if the other thing is the same base, but 2 is not. So it just stays like this. Which form is this? Exact or approximate? Exact. So this is exact form. Use your calculator real fast to find approximate form. By the way, the reason why we're doing approximate form is because 10 to the 1.35 divided by 2, that probably doesn't mean much to your brain, okay? Natural log of 3 divided by 0.4, doesn't really mean much to your brain, but you can comprehend decimals. Like, you know that.